So good morning, everyone. Good afternoon or good evening, depending on what time zone you're in. And so as Ed says, my name is Raymond Austin. I'm the Director of Marketing here at HashiCorp. And today we'll be talking about Consul and how Consul provides cloud networking automation for your business. And a little bit about the company, about HashiCorp. So we were founded in 2012. We have north of 600 employees here at the company and growing. And what we do is we provide a software stack with a set of workflows around four areas: provisioning with Terraform, security with Vault, networking with Consul, and the running of applications with Nomad. And so today we're here to talk about how we can unlock the cloud operating model for networking, which is all about Consul. And so what I'll do is I'll step through, as part of the agenda, I'll step through and provide a little bit of context around the industry and some of the key challenges we're seeing. We'll talk about what is Consul, how does it help solve these challenges. We'll step through a couple of the key use cases. And then we'll go into a little bit about the maturity model, which is very useful to understand how customers are actually using Consul and over a period of time, what they're doing with it. And then we'll talk about the broad ecosystem that Consul is a part of, and then we'll wrap up by answering any questions you may have. Okay, so with that, why don't we go ahead and get started? So yeah, I wanted to start by providing some industry context around the impact of networking to a couple of core KPIs. The first one is around agility on the left, where organizations continue to seek to improve application delivery, but are often stymied at the networking layer. And so according to a recent survey, 75% of companies, in fact, report taking days or even weeks to complete networking tasks. And these tasks can stem from the lack of being able to automate configuration changes, to being able to drive insights and using analytics to figure out what is the long pole in the tent, right, regarding what's contributing to why it's difficult to complete these networking tasks. On the right are a couple of core KPIs around core KPI around security or reduced risk, where perimeter firewalls are not effective in preventing lateral movement, which happens inside the customer's high trust zones. And so, according to another recent survey, 90% of cyber attacks stem from lateral movement attempts, right, that occur within a data center, right? So not outside of the firewall, but within the high trust zone. And so when you think of the KPI here on the right, this is the target breach that happened a couple years ago. Okay, so all of these challenges can be, both of these challenges can be quite concerning to an organization, and it becomes important to understand what are the underlying causes of these networking challenges, and what are the solutions that can help solve them. So a good place to start is to look at the baseline, where one point in time, networking in the data center was relatively easy. You had monolithic applications with long-lived IPs. You had a well-defined north-south traffic pattern that starts with ingress leading to a load balancer or a set of load balancers at the edge of the data center, connected to a set of firewalls, and you oftentimes had a typical three-tier architecture where you had your DMZ zone, which was public-facing. You had your application tier, and you had likely a separate database tier, right? So things were relatively straightforward. You were okay with deploying perimeter-based security. But what happens when you move to a cloud environment, and especially a multi-cloud environment? And what happens when you're starting to deploy modular applications with more dynamic IPs? And so what we see in terms of the effects of digital transformation from various organizations and companies are that they're moving away from traditional data centers with dedicated infrastructure to more modern data center environments with more dynamic types of applications, right? So you have your systems of engagement applications, like your email and your mobile apps that are spun up directly in the cloud. You have your traditional systems of record applications like ERP and database, which is often still hosted in either an on-prem or environment or a private cloud environment. And then you have newer types of applications that are being spun up, right? So you may have a machine learning project that is hosted in GCP with TensorFlow. You may have, through a consolidation effort in your business, a number of different groups using Active Directory that's hosted on Azure, or you may have gone through an acquisition where another company is an AWS shop, and they have a lot of archival applications that are using S2, right? And so all of these sort of scenarios require a multi-cloud approach in deploying and managing these applications at scale as part of a broader application lifecycle. And this means reimagining the stack across several areas: provisioning, security, network, and runtime. And the implications of the cloud operating model for networking means that you're moving away from a static-based environment, so you may have only a few firewall rules, to now you're in a very dynamic environment, right, with IPs that continue to change, with many different firewall rules. It's hard to keep up, and then you have applications that are now broken up into fine-grained services. And so as it turns out, the search of a common model across multi-cloud environments becomes quite difficult, right? Because the cloud landscape today is fraught with different siloed approaches, right? Whether or not it's a hardware approach for dedicated infrastructure, or you have proprietary approaches in the public cloud. So, for example, you may have app mesh from AWS, or you may have Istio from GCP. And so now the shift from static to dynamic networking looks very different, right? And so now you have modular services with dynamic IPs. You may be spinning up services with auto-scaling groups. You may be running not your traditional application servers, but you're running into containers. You have your virtual machines which are part of the legacy infrastructure environment. So the diagram here at the top looks very different than the diagram that I showed earlier on, right, with a typical north-south traffic pattern. You're starting to deploy load balancers and firewalls connecting different applications and services together in more of an east-west traffic pattern. And in fact, according to Cisco, 85% of the volume comes from this complex east-west traffic, right? And so now you have no clear network perimeter. And all of these challenges requires a different approach to networking and security. So what is Consul? So Consul provides a foundation of cloud network automation for services-based networking. The best way to think of it, the way I think of it, is it's a software-based approach for connecting and securing services across any runtime platform and cloud environment. And there are three key use cases with Consul, and I'll talk about them in more detail later on in the presentation. But in summary, they include being able to do health monitoring through a central service registry. And so think of this one as Consul being used as a real-time directory or phone book, right, of all the different services that are connected, and being able to determine their health status. And this turns out to be a use case that quite a number of our customers adopt early on in their journey around microservices and distributed cloud environments. The next use case is around automating network middleware devices. So these include load balancers and firewalls, and being able to dynamically reconfigure them as services scale up, down, or move around. And then the last use case is around being able to implement zero trust networking with a full service mesh. And so for this particular use case, Consul, a lot of the authorization and routing features are now moved to the distributed endpoints. And this simplifies the network topology tremendously, right? So there's a lot of the east-west firewalls and other network middleware devices that can be eliminated by adopting this approach, and that you're using Consul uses mutual TLS to fully encrypt the service-to-service traffic, and that now you're incorporating security policies based on logical services and not service names, and not simply IP address. So Consul is a full product with a number of different capabilities. It's been around since 2014. It's had over 1 million monthly downloads per month. And it's used in a number of very high-end and scalable environments, right? So we have a number of production customer environments with north of 50,000 agents that have been deployed. So what is the guiding principle behind Consul? And we look at the guiding principle as service-based networking, where operations teams can completely decouple IP addresses and then spin up services and register them using Consul and its integrated DNS. And that provides a framework or a background, if you will, to do things like automated networking and security based on logical services, right, rather than IP addresses. The other concept behind, or guiding principle behind service-based networking is the concept around identity, where instead of IP address 1 talking to IP address 2, you have services A being able to talk to services B. And so the great thing about Consul is that you can deploy it in an on-prem environment, in a public cloud environment, across regions, across multiple data center environments, right? It really truly becomes a unified networking solution for multi-cloud. And so this is a huge benefit for customers who have to go through the journey of taking their existing network environment and having to evolve that in a more modern data center environment. And so in terms of adoption, we see customers follow a common maturity model that allows them to realize the value immediately as they deploy Consul, initially as an open source offering to both the individuals and practitioners within the organization, and then later on deploying Consul in production within enterprise, a number of enterprise environments. They may be adding more use cases, right, because they're starting to generate more value with Consul for their enterprise. And then over time, being able to scale that even further. And Consul provides a number of enterprise features to increase resiliency in their environment and also support additional requirements such as compliance and governance. Okay, so what I'm going to do now is to shift gears and spend a little bit of time talking about the 3 use cases with Consul. The first one is around health monitoring using a central service registry. And so for this one, as I mentioned, this one's about Consul being able to provide a real-time directory of what services are running, where they're located, and their overall health status. So the screenshot on the right is a screenshot that shows all the healthy instances of services, right? That it's indicated here on the green. And the main problem that exists today is that there's a lot of disparate tools that are out there that do something similar. So some customers use spreadsheets to track IP addresses and names and things like that. They may be using CMDB tools, or they may be using single-use tools. For example, Kubernetes has some service discovery features in it, but it can only be used for Kubernetes, right? So if you want to extend beyond Kubernetes to other cloud platform environments, you really have to go have this hodgepodge of different tools, right, at your disposal. And with Consul, it's a single unified tool to be able to get that visibility into your services, into your running services, and determine the health status. And so the net benefit for this one is higher resiliency, because you're able to troubleshoot and understand where are the unhealthy services that are out there, and to be able to reduce downtime from that. Okay, the second use case is around network middleware automation. And so this one, Consul, and this is the idea where Consul uses what we call a publish-or-subscribe model, where services publish their location using Consul's service registry, and then the network middleware device, maybe it's a load balancer or maybe it's a firewall, can then subscribe to these changes from the service registry, and then they can populate their own backend pool configurations. And so the benefit here is that you're going away from very manual ticket-based approaches to updating middleware, especially in a very dynamic environment. So this ties in to the earlier challenge or customer challenge that I talked about around how long it takes to oftentimes networking becomes the long pole in the tent for deploying applications, and a lot of that stuff comes from how much time is incurred from from waiting for these tickets to be approved so that these load balancers and firewalls can be updated. We provide a couple scenarios here to help with this, to help customers in this particular use case. One is to automate existing network middleware devices. So you have some existing load balancers and firewalls, and you want to update that. And so, we have with our API and our console template, we're able to make it very easy for you to automate your existing devices. The other scenario is, and we've seen a number of customers with this scenario, which is using console to discover and connect directly without any need for additional east-west middleware devices. And so the benefit here is that you can substantially reduce your cost by eliminating the need for east-west network middleware. Okay, the last use case is around zero trust networking with service mesh. And so as I mentioned earlier, this one, what we're doing is a lot of the authorization and routing features are now at the distributed endpoints. And then this makes the topology a lot simpler, right, and easier to manage. It flattens the network. It removes the need for expensive firewalls that within the east-west traffic paths. And now we can encrypt traffic with mutual TLS between services. And now you can deploy policies that are defined using the concept around intentions and identity versus IP addresses. So I intend, web server A to talk to database server B, right? And so the overall benefit of using service mesh is you can substantially reduce risk with consistent end-to-end security enforced across, not just a single platform environment, but across a heterogeneous environment. And so this ties in nicely to the challenge that we talked about earlier around, these breaches that are occurring within the perimeter firewalls. Okay, so the way to look at console is that it's a single control plane to manage, configure, and automate using via a pluggable data plane. So the data plane here at the top, there's a number of different devices. There's load balancers, there's proxies, there's firewalls, API gateways. And then at the bottom, we provide unified support across a broad heterogeneous environment, right? So we talked about different cloud platform types, different cloud providers, and also a number of infrastructure IHVs and ISVs, so certificate authority platforms, identity management, application performance, logging, things like that. So we provide a single workflow that allows for simplified operation across this broad ecosystem. And so you see here that we have a number of different IHV and ISV partners that we work with to build out the different types of solutions across a broad ecosystem, right? So we have joint relationships with many of these partners to build joint solutions that include reference architectures, learn guide material, videos in terms of how to install and deploy across this broad range of integrations. Okay, as I mentioned earlier, we offer a number of enterprise features beyond our open source version to support larger teams and organizations, right? So these include being able to improve platform reliability, being able to reduce downtime through automated backups and upgrades, being able to support advanced deployment patterns to improve resiliency, and to manage very complicated network topologies that exist, especially in a multi-data center environment, to improve scalability or meet regulatory compliance requirements, or simply reduce cost. Okay, and so to summarize, Console provides a single workflow to enable a new software approach to networking and security as part of a broader common cloud operating model that allows you to provision, secure, network, and run your applications across any real-time platform and cloud environment. And so there have been a number of companies that have publicly talked about their use of Console. These are companies that are either born in the cloud, startups, and even traditional enterprise businesses. And for many of these customers, Console underpins their core infrastructure. So I would highly encourage you to visit HashiCorp.com to get more information on the types of customers that are using Consul. And so thank you for your time. So now I think we'll take some questions. Ed, are you there?
Yes, I'm here. So now that we're ready for questions, you can add them. There should be like a little questions section here within GoToWebinar. So please add those questions in there, and then we'll go through as many as we can in the time frame that we have left.
Okay. Yeah. As I'm trying to pull up the list of questions, so one question came up. Do you support layer 7 features? Yes, we support layer 7 features with 1.6, version 1.6, which was GA'd about a month and a half ago. And we're seeing a lot of customers interested in the ability to do things like traffic splitting, which is a very popular use case for developers for things like canary testing and A/B testing, where they want to roll out roll out new changes to code to a certain subgroup of people, right? And so this is accomplished through traffic splitting, which is a core feature of our layer 7 update. Let's see, what else? What observability features that you provide? So we work with supported proxies like Envoy to provide detailed metrics around things like connections, timeouts, retries, things like that. We also work with observability vendors to provide some higher value and joint solutions around things like tracing and APM, application performance management, things like that. Okay, what proxies do you support? So Consul includes a built-in layer 4 proxy, and then we have first-class support for Envoy, which is layer 7. We also work with other proxies as well, like H8 proxies. Okay, do you work with Kubernetes? What Kubernetes features work with Consul? Well, yeah, so we have first-class support for Kubernetes, and over the last year, we have built a number of different features that integrate natively into Kubernetes. So things like being able to deploy Consul into Kubernetes using Helm charts, to be able to sync Consul and Kubernetes environments together with a number of different features there. So yeah, we'll continue to integrate into Kubernetes by building out the additional features over time. Okay, I think that's all the questions we have so far. Anything else, Ed, you want to mention?
No, I think let me just see if there's any other questions over here. We have one around certification path available for Consul. I don't know if you have anything to share there.
Yeah, well, so I would for that I would probably go to the IO site, the Learn site to get more details on specifically what certification path you're referring to. So I'm not quite clear. It depends on what it is, but yeah, feel free to go to Consul.io to get that information. There's another question around how does Consul differentiate from some of our competitors. So as I mentioned, Consul has been around since 2014. It's a fairly robust solution, and a number of customers report that there's proven scalability with Consul, especially in some of the larger production environments that we've seen Consul deployed in. And in terms of operational simplicity, it's very easy to use and deploy. It's a single binary that can be deployed across your data center environment, as opposed to other solutions out there that require multiple binaries that are installed. Let's see, what else? Would you please share the presentation slides with me? Yeah, we can. Ed, I think we will make this presentation available as part of a recording, correct?
Yeah, we'll definitely follow up with the recording and the slides as well.
Okay. It will be really nice to see a demo. Yeah, we have a number of demo environments. There's tons of demo environments with console out on the HashiCorp.com, both IO and .com site. So I would encourage you to go there, and there's demos around our 1.6 release. There's demos around how console is used along with other ecosystem integration partners, for example, F5, for being able to automate network middleware. So yeah, I would encourage you to go to the website to get that information. Let's see. Yeah, so there's a question around integrating with other scheduler environments, and so yeah, we have a quite extensive list of different different scheduler environments that work with console, and I would encourage you to go to HashiCorp.com to get that list. I don't have it with me, but that information is provided on HashiCorp.com. Okay, yeah, so there's a couple of other more technical questions that I would ask if you could go to HashiCorp.io to get the answers to them, or feel free to go to our support to answer. I wish I could answer some of these more technical questions, but there's a ton of information that is on the website. So with that, I think that about wraps it up, Ed.
Awesome. Yeah. So we will definitely send out the recording fairly soon. So it usually takes about a day or two. So you should get that in your inbox as well. We will also do a small export of all your questions. So if there's anything that we missed right now, we'll be sure to follow up after the presentation as well. But thanks again, everyone, for joining this webinar today.